You are evolving into a crab. Well, probably not anytime soon, but this is real. It is perhaps the strangest phenomenon still happening today. Many animals are becoming crabs. Take a look here. This is not a crab. That is not a crab either. None of these are crabs. They have all slowly, over millions of years, become more and more like one. This phenomenon is so widely studied in science that it has its own name, carcinization. If you translate it from Latin roots, it essentially means crabization, the tendency for things to become crabs. Of course, this sounds ridiculous because it is, but when we look into nature, we see this effect everywhere. Some did it millions of years apart. Some did it in totally different oceans. Some were not even remotely related. Why does it seem like this is the ultimate life form for all animals? What stops us from evolving into crabs next? This crabification effect has been joked about online, with hundreds of memes about crabs being the epitome of all life. And well, this is actually right. Scientifically, this is peak performance. But how do we know this? The best explanation for this goes back to an effect called convergent evolution. Essentially, this is when two different organisms that deal with similar challenges end up evolving the same traits independently. If you have watched our video about massive squids, you would know that two different squids have both evolved to become massive, even though they are completely different species. Being giant benefited them both, so both became giant. But why crabs? And why do we see this so often? To get that answer, we need to understand what crab-like actually means. Because not every creature that looks like a crab is a real crab. Some, and actually most crabs, are just evolutionary imposters. A crab-like body usually has a wide, flat shape that keeps the center of gravity low and makes the animal stable. That flattened design also lets it slip under rocks, hide in tight spaces, and avoid getting flipped over by waves or predators, because the last thing you want is to end up like this. Crab-like bodies also obviously have a shell, but it is more than just armor. It turns the entire body into a compact tank. When your whole shape is basically a shield, you survive a lot more things than creatures with long, exposed segments, like lobsters or shrimp. Crabs also have short, powerful legs that give them insanely good control over their movement, hence why they can move like this. They are actually better at moving sideways, which helps them dodge predators while still being able to face them. But this raises a really interesting point. If the crab shape is so effective, why is everything not turned into lobsters instead? Lobsters are strong, armored, and successful too. So why don't we see lobsterization? They are still alive today. Clearly, they have also survived millions of years. Well, the lobster body plan is actually way harder to modify. Lobsters have long, segmented bodies with big tails. You cannot flatten a lobster without breaking half its anatomy. The moment you try to squash that long tail under the body, the whole structure stops functioning. Crabs, on the other hand, start with a compact shape that is incredibly easy to tweak. Their body plan can widen, shorten, armor up, or shift direction without ruining their movement. Once you become crab-shaped, it is very stable. Species rarely stretch back out again. Becoming lobster-like again would require re-elongating the abdomen, rechanging musculature, remodifying tail fins, and restructuring the whole body. Those changes are much harder to evolve than simply shortening the body and tucking the tail. Carcinization is mechanically easy. So, who was the first crab to become a crab? Technically, the earliest true crabs showed up over 200 million years ago, back before dinosaurs were even alive. But the interesting part is that they were not alone. Around that same time, other crustaceans started evolving into crab-like forms too. We don't call them true crabs because they were somehow more authentic or biologically superior. Most of it is, they were simply the ones we discovered first. Back when scientists were first trying to categorize animals, they had no clue about genetics. They were working purely on appearance. So animals in that group were what we defined as the real crabs. In a way, these are the first animals to become crabs, real crabs themselves. Which sounds really redundant, I know, but it does point out the fact that they are included in the effect of carcinization. They didn't create the design themselves. We just dubbed them the official crabs. So what other crabs are there that aren't real crabs? Well, the most famous imposters are king crabs. Genetically, king crabs are actually giant hermit crabs that evolved out of the living in a snail shell strategy. Their ancestors used to carry shells on their backs, just like the tiny hermit crabs you see on beaches. But over millions of years, they evolved a hardened body of their own, lost the need to swap shells, and flattened out. Even though king crabs and true crabs look way more similar on the outside, they come from completely different branches of the crustacean family tree. Their last common ancestor wasn't a crab. It was some primitive crustacean, hundreds of millions of years ago. We obviously can't say for sure what they looked like, but they definitely didn't look like crabs. It is interesting, because anyone who has eaten king crab versus normal crab with any frequency would be able to tell the difference from their taste. But what other things have turned into crabs? Well, take a look at porcelain crabs. Is everything that is not a crab called a crab? See? Part of the problem is everything that looked like a crab when we found them was named to be one. Porcelain crabs belong to the order Anomura, the same branch as the squat lobsters, and they are actually incredibly similar to them. They don't fight like crabs though, and their shells break much more easily, almost as if they are made of porcelain. And carcinization has occurred in crab-like species before crabs even existed. Fossils show that carcinization has been happening long before true crabs even existed. We see this same body type with flat, wide bodies and tucked-in tails over and over, as if evolution can't help but keep wanting to make more crabs. But if being a crab is such an ultimate life form, then where are these crabs now? Well, most of these early photo crabs are actually completely extinct now. The problem was, they literally weren't good enough at being crabs. Some lacked the hardened shell. True crabs eventually evolved. Others didn't have the right leg structure for that sideways, ultra-stable movement. And a few were living in environments that completely collapsed during mass extinction events like the asteroid that killed the dinosaurs. But even if their descendants didn't survive, evolution remade their crab design again. It is built into the way our universe works that crab-shaped bodies will continue forming, as these are just effective builds for crustaceans. The crabs of today are the most successful crab designs that have existed so far. But what else can or will turn into crabs? The scary answer is anything in the right environment. We have seen tons of animals drift towards this crab shape. Even some shrimp lineages are showing early signs of flattening out and tucking their tails, the first baby steps on the long road to becoming a crab. But in reality, this process only really affects crustaceans to the full or any extent. We won't actually be seeing lions becoming crabs anytime soon. Their builds are for completely different environments. Humans, especially being the dominant species on this planet, are not likely to evolve into crabs either. You are safe, for now. But something really interesting to look at is that other animals have evolved similar body shapes as crabs for similar reasons, even if they are not crustaceans at all. Take stingrays, for example. They are not crabs, not even close, but they ended up with a body shape that is surprisingly similar in principle. A wide, flattened body that is built for stability on the seafloor. Just like how crabs flatten out to stay low, stingrays flattened out to glide through open water with almost no drag. So does this mean stingrays are becoming crabs too? Well, no. But they are shaped slightly similar for a similar reason. A case of partially convergent evolution. It is not carcinization. It is not stingrayization either. It is just flatization. Everything is relative after all. You see these examples of partially convergent evolution in animals all the time, actually. We just don't often think about it. Look at dolphins and sharks. These two animals could not be more different biologically. Sharks are ancient fish with skeletons made of cartilage. Dolphins are warm-blooded mammals that breathe air, nurse their young, and are more closely related to cows than to anything in the ocean. Yet, put them side by side, and they both ended up with almost the same streamlined, torpedo-shaped bodies. Because that shape is simply the most efficient way to move fast through water. If you want to cut through the ocean with low drag, stay stable at high speeds, and use as little energy as possible, evolution starts pushing you towards that same sleek, pointed design. If you want to stay close to the seafloor, you end up becoming flatter. Birds, bats, insects, even pterosaurs, all figured out the same basic design because the physics of flight leaves you with only a handful of options that actually work. The environment that we live in only gives us a select amount of blueprints available to choose from. Thank you for watching.